Hello, everyone. I'm Allen Firstenberg.
And I'm Noble Ackerson.
And we are Two Voice Devs.
Two Voice Devs.
Live and in person here at Voice+AI 2023. Hello, everyone. So, for many of you who are currently staring at the stage wondering, who are these two fools, aside from the Two Voice Devs, Two Voice Devs is a podcast that has been going on for about 3 years now. Originally, we started talking about voice technology for developers, how developers could use things like Alexa and Google Assistant and Samsung's Bixby to reach other audiences, to do things that we thought were cool and innovative, and most importantly, helping people in new and different ways. And as the AI technology has grown, just like everyone else, we've started pivoting and moving into that space. So we're now here talking about LLMs and thereabouts, and I've brought with me my guest host for this week, Noble Ackerson.
I'm glad to be back. I'm choked up about it.
I can tell. So what we would like to do ultimately is field some of your questions about AI and LLM, maybe even voice technology, but kind of get a sense for what questions you have, and we will either try to answer them or come up with something that sounds plausible. We can play like we're ChatGPT. But no, really what we want are your questions and your input to kind of guide the conversation. And we're happy to carry on from there. So
I have a question for you right away.
You have a question for me right away. This isn't going to be good.
Off the rip. So earlier, great talk, by the way.
Thank you. So for those of you that don't know, I spoke earlier today about open source software. Noble, you're going to be speaking later. What are you speaking about?
I'm going to be speaking about how generative AI is an unreliable information store and why I'm terrified that it's being used in search.
That is terrifying. I agree with you there. So what's your question to kick us off?
But my question is about your presentation.
Okay.
Right? You talked about LangChain and your contributions to LangChain.js.
Well, I talked about LangChain. I didn't talk so much about what my specific contributions were.
Well, maybe yes. I'm reaching. Specifically, though, A61Z, this massive VC out there in the Valley, talks about LangChain, Llama Index, and these tools, describes them as orchestrators.
Yes.
Others describe them as software development kits, SDKs. How do you describe LangChain? What is it?
Well, it's a good question. I mean, I never liked the term software development kit because I don't think it has any meaning. It's kind of vague about what an SDK is. An SDK is literally something that helps you, that you need to develop software. That's kind of broad. I guess I view LangChain as a lot of things. One of the things I talked about it being an aggregator or a facilitator in my presentation this morning. I guess kind of the big thing I see it as, though, is as an abstraction layer.
Okay. And
abstraction layers are important for a lot of reasons, but one of the things that they do and that they enable is they enable more people to access more things. So, for example, Pete Erickson this morning in the opening keynote related large language models and the dawn of the large language models to the dawn of the relational database, and how relational databases were, up until that point, kind of the domain of a privileged few. It wasn't until after that we got the abstraction layers. We got not just SQL, but SQL that worked almost the same everywhere. That we got the database drivers so that I could write a program and use one driver to talk to Oracle and then just switch drivers and talk to MySQL without having to change anything. That democratized it. That made it so that I didn't have to be a specialist. I could generally understand databases and work with them. LangChain provides that kind of model for LLMs. So now instead of having to think, well, I'm writing something for ChatGPT. I can now say I'm writing something for LLMs in general. And I might start with ChatGPT and I might test it on another platform and find which one works better and tweak my prompts for, whichever one works better. So I can now change platforms to where it's going to be cheapest or where it's going to be fastest or where the LLM is best suited for what I need it to do. And then I'll do the same thing for vector databases. And I'll do the same thing for document store. And I'll do the same thing for anything else.
But, okay, so I'm asking the questions now, but this is for you guys to ask questions as well if you're interested or something burning. We may not always have the answers, but through this conversation, this dialogue, maybe we can all get smarter with it. So I got another follow-up question for you. So I tried out LangChain when it first came out with, my little toy project, and I found it to be a nightmare to wrestle with. I wanted just one abstract. I just wanted to use, let's say I wanted just to use sort of the templating, just use the variables with the templating,
Yes.
prompt templating techniques that it uses, and not all of the other cruft. But it comes with all of that overhead when I'm just trying to solve a specific problem, depending on my little toy use case. Like, you talk about it being an abstraction layer of some sort, or an abstraction orchestrator of some sort. How does that overhead sort of play into how you use it? What advice do you have for me?
Well, I think some of the good news is over time they've been able to whittle that down. So you're no longer dragging in the OpenAI library if you don't need OpenAI. You're not dragging in lots and lots of extra stuff. If you're going to use it, you need to add it. But it's not going to be there. And other than that, yeah, you've got a sizable library with all of these abstraction models. But unless you are loading in a particular class, it never gets called, it never gets initialized, there's no overhead. The only overhead is you've got a library. So it's whittled down a little bit over time. I think it's still a problem though. And I think certainly in terms of runtime, we're going to get to the point where we're seeing the pre-compilers that are just going to load in the components that are there. We see these sorts of things with JavaScript and with TypeScript now, and I can see them easily being used as we're going forward. So I can see those as the sorts of things that we'll see. So again, we've got a crowd that is slowly starting to build here, and it's always exciting to see a good crowd here. If anybody does have questions for us, feel free to raise your hand and shout them out. We will repeat the question, though. I see a hand here. Yes. What do you got? Oh, we'll try the microphone. Good.
Microphone, yes. My question is about voice technology and generative AI. I appreciate your concerns there, but have you seen any use cases where the two have been kind of merged together using voice technology and also LLMs or any level?
Can you just repeat that? Because I'm not sure I fully heard it. No.
So I believe the question was other use cases for large language models with voice technologies, right?
Oh, excellent.
So my first go-to is voice synthesis technologies using large, basically that same technique. Instead of passing tokens, you're passing bytes, right? There's audio. I've seen some pretty, the name is going to slip me. There's an attorney, believe it or not, that has a side hobby of sort of creating music. And what he did was fine-tuned, or perhaps not even fine-tuned, but basically trained a bunch. I should qualify that he's a patent attorney, right? And so basically recorded, a bunch of sample songs and all that stuff that were public domain. And then has his generative AI solution, audio-based generative AI solution, create new music based on the patterns that it has. Now I may need to dig into my phone to try to figure out what his name is and give him a plug, but that just blows my mind. What he's done now is that he's generated so many sounds and so many tracks that he's, as a patent attorney, he's actually made those all public domain. So now because you want, and I think that's a noble, no pun intended, but that's a noble thing to do, right? Because you have a scenario where at some point when these tools or techniques or approaches become so ambient in our lives, you're going to have those money grabbers, those, law firms that just want to sort of sue everyone. We already heard, there's some lawsuits coming in, Drake's AI and all that stuff. Those are all, I'm not a lawyer, but that sounds like that's fair use of something, sort of a transformative art in some cases, and that's a solved problem, at least case law.
But it's only barely a solved problem.
Well,
it's still highly contentious, and it sounds like he's kind of knocked the knees out from under that.
Right. And so that is my point, is that he's going to use that to sort of buttress, making some of these innovations open, at least voice innovations open for all. That's my thought there. I don't know what.
So I think it's a good question. I think where I see these LLMs being used when it comes to voice is on generation, on output. There are caveats here for sure, but one of the things that we know how people respond to responses, what they hear, is they detect very quickly if you're repeating the same thing over and over, or if you're repeating something and just filling in a blank. We're tuned to that. We pick it up, and our brain tends to start fading it out. We'll filter it out so we don't hear it anymore. But when we introduce variation in the responses, we're better at picking up the entire response, including the part that we're interested in. So for example, if I ask, what's the temperature? If every day you're answering, the temperature is 73, the temperature is 54, I'm going to tune it out. But if instead, I don't know exactly what the answer is going to be, it could be something like, well, it looks like it's going to be 73 today. Or, hey, I got good news, it's going to be 73 today. If I'm switching it up and varying it, then the human brain will pick up on it better. And maybe it makes sense for us to use LLMs to create that variation. And not just to create that variation, but also to know what other information we should be including at the same time. To, again, make it more interesting, have people listen to it, keep people engaged with it. And I'm sure, the biggest challenge though, and I think this is the kind of flip side and the caveat to all of it, is that we also know that from the voice industry, responses need to be fast, really fast. The guidelines for Amazon Alexa and Google Assistant were basically saying you needed to reply within 5 seconds. And that's long. 5 seconds is a long time. We can't wait that long for our LLMs to reply. And they're taking longer now. So we really need to get our LLMs to come up with that reply a lot faster. And I think that's the biggest challenge with using LLMs in voice these days.
And there's some modalities that, within your car. There's Antonio from Mapbox is here. He's working on generative AI for in-car experiences. Imagine asking for a command, and like you were saying, how long it was, and having to wait, how many seconds?
5 seconds is a long
5 seconds. Time. You'll never use that infotainment system again. You'll just go rip it out and get a new one, right? A lot of what I'm going to be talking about later today in my talk at 325, Gen AI, an unreliable data store, and what to do about it. That's a very long name for my talk. Join. What I'm actually going to be talking about is some of the trade-offs in trying to make these tools more reliable. And in adding that complexity comes some of the latency issues and the length of time. So it's like a squeeze toy, right? You optimize for one thing and constrain on optimization for one thing, and then you sacrifice another, like with any software decision that we make. And so by sacrificing the quality of the output and the factual correctness of the output that I may want in my audio experience, generative AI experience, I may sacrifice the time that it takes to retrieve something from using a RAG pipeline or whatever from a database, whether it's local or especially if it is cloud-based.
Yeah.
There's a cost there. So.
Well, I think the funny thing we talk about, and again, before we continue, if you've got questions, raise your hand, come up over here, we'll put you on mic to ask the question. But I think the important thing to think about is, we always say things like, cloud is the killer when it comes to latency. Right now it isn't.
Right.
I mean, that's not where our speed performance is. The latency on the network is really, really low. The latency in the LLM, in the processing, that's ridiculously high.
Right.
So at least right now, it's not going to be this way forever, I hope. Although, I think there are built-in constraints with an LLM. But right now, the network is not the problem.
Right.
So I think we had another question. Did you have a question?
Well, one of the observations that I have is that if people are willing to tolerate lag, if what the answer is would take them longer to do than just simply asking the question and getting the answer back.
That's a very fair
Right.
point, yes.
So if you ask it to do something complicated and it does it well, people are willing to be more forgiving as long as you let them know they're going to be about to wait.
Well,
I think.
and I think that's very true, but I think it goes back to the modality of the communication. As humans, we're kind of we handle written lag fine, and that's why ChatGPT was so successful. Is that it'll sit there for a few minutes and it looks like it's doing something, and it'll get back to you. The problem is when listening, your immediate reaction is this thing on? Did it hear me or did it not hear me? So we need to close that immediate feedback loop. Maybe the answer is immediately we need to say, hang on a second, to give that immediate feedback. And then, if it takes a little bit longer than a couple of seconds, play the hold music or whatever. But and again, we know from experience of call centers, we can't just leave you hanging. You need to think that something's going on.
It's a UX problem.
Yeah.
Do you remember, actually this goes to your question as well, like generative AI use cases in audio. So I talked about audio synthesis. Do you guys remember Google I/O maybe 4 years ago? They did this mind-blowing demo where an AI called a restaurant and it sounded human. You remember that?
I remember it well. I remember all the people complaining about it afterwards.
Expectations and all that stuff, those are all solvable UX problems. Announce who you are, I'm an AI, and I'm calling on behalf of Noble, and da-da-da-da. But the point I was trying to make with that, to go to the latency question, or that delay, is that it's a UX problem. Do you remember how they solved the sort of I'm thinking problem?
Oh, sure. They introduced disfluences.
Like?
Like that.
Exactly. So as the person was talking, it sounded more natural. Like it's like, the person on the other side of the line at the restaurant perhaps would ask, what time do you want to, how many people do you want to seat for this appointment? And it'll go, it's retrieving. It goes, maybe 4 people. Right. The milliseconds that it took was processing time.
Right.
But it sounded very human.
No, it did. A person who's frequently at these voice conferences, I don't believe is here this time, Brian Ramel, often speaks about his voice assistants would have disfluences when it was doing network access. So his big thing was that his AIs are live and local, and everything is handling and processing locally. But when it does need to go to the network, if it takes a little bit longer, he introduces that disfluence to both let the listener know that it's still working and that it had to go off the local network. So it's those kinds of tricks that I feel like, and this is something I've said a couple of times, is that there's a lot that the voice industry has to give to the LLM community as a whole. We've learned some really, really hard lessons over the past 7 or so years with Google Assistant and Alexa. And the LLM industry really needs to learn some of them. At the same time, we need to be taking stuff from the LLM industry, the rapid pace that's coming out, the stuff that you're building and discovering, we need to incorporate those faster into voice.
That was a great question. And great questions so far. Are there any other questions?
So while we're waiting for some more folks to step up, you're speaking this afternoon on
325.
On truth and LLMs.
Factual accuracy, yes, truth,
Okay.
and reliability, all sort of themes around data trust, right? Yeah.
So I know part of what kind of sparked your journey on that one was suddenly discovering that you were dead.
Oh, yeah.
You want to briefly tell folks about that?
Yeah, so I'll talk about this later, but on sometime in February, you couldn't like look left without seeing OpenAI being mentioned, or hear OpenAI being mentioned, or see somebody talking about ChatGPT. It was everywhere. So the first thing I do with any new technology,
And don't we all?
if I can, is to ask it about myself, because I'm egocentric. And so I said, tell me what you know about Noble. And it wove this beautiful tale about how I was a successful entrepreneur. I sold my company and started a nonprofit in West Africa, Ghana. And then I died 4 years ago. And so, I went back to the OpenAI docs. I go like, well, how do I make this thing convince it that I'm not dead? It's like you have to, the instruction was to coax through prompt engineering. I don't know what that meant at the time. It was February. And so the thing had just come out like a week before. At least I had access to it the week before. And so prompt engineered my way to try to convince it that I was alive. It was like yelling at a PA speaker.
Right. And I feel like, it's not surprising. My experience with truth using ChatGPT, and again, this was around the same time frame, and people were saying grand things like, ChatGPT has unveiled the future of education. Now anybody's just going to go to ChatGPT and ask questions and have a conversation and learn anything. So I asked it about sugar. And it gave me some information about sugar. It gave me the chemical formula. It gave me what it was composed of. And I kept asking more and more questions. And at some point I realized it's giving me information that sure looks right.
Right.
But if I add up the numbers, they don't add up. There's more carbon atoms than it says there should be. And when it breaks up, there's more hydrogen and oxygen. There's
Right.
too little hydrogen and oxygen. What's going on? And no matter what coaxing I could give to it, I said, so when you do this, where's the extra oxygen and hydrogen? There is no extra oxygen and hydrogen. If I do this, is there any other reaction? Is there any side products? Is there anything? And it insisted there was not. And these are the sorts of questions that if I hadn't caught that little bit of information, I would not have known that it was spinning a fantastic tale.
It sounded relevant. It sounded factual.
It sounded totally factual.
And if you are an attorney from New York named DeLuca, you may be out of a job right now and disbarred.
So in that
Please don't
story,
sue me.
for those that don't know, there was an attorney that submitted briefs in a case with citations, legal citations even. They were citing case law, and the judge reviewed it and said, none of this
None
makes
of those
sense.
exist.
And when the judge went to look up the case law, said, these cases don't exist. Where did you get this from? And he said,
Oh, it's just OpenAI. ChatGPT told me, and it has to be true, right?
so I think there's I'm really interested in seeing your
So
presentation.
that's
letter.
literally the talk, right?
Yeah.
So I'm going to be walking through that. I may not talk about this part anymore because we just did that here. But I work in the enterprise, right? And so the notion that you're going to just sort of lift and shift this technology to solve enterprise-grade problems terrifies me, right? I don't care if you're in marketing, if you sell a widget, or if you do TPS reports for a living. As a putting on a product hat, you know, correctness, the factual accuracy sort of drives trust within an enterprise. And without data trust, you're going to sacrifice adoption, right? And if there's no adoption, you lose your marketing dollars or your engineering dollars. Demos are great. But what I found in 6 months in the field working with generative AI systems is that those demos fall over, crumble, the second you put them in real-world situations. So I'm going to be talking about some techniques and a framework that I've built to sort of help my clients and customers sort of think about that. Yeah.
So again, we've got a little bit of time left. If you've got questions for us, if you want to challenge us, if you want to see us duke out an answer,
We disagree
come up and
on
ask
a
a
lot
question.
of stuff, Alan.
And we do. You know, I think that's one of the things that is a hallmark both about our friendship and when I have you on the show and the show in general is that we really try to get different perspectives. We're not standing up there agreeing all the time.
Makes for a terrible show.
It does make for a very boring show. Just like a lack of questions right now is making for a kind of boring show.
I think this is a great, I'm having a
not
great
judge.
time.
No, but you know, the fact that we can disagree and find the common ground or find the common disagreement, I think is crucial. Another question, great.
You guys mentioned about network latency when asking questions using voice. So is there a way to, I guess, what company is out there solves this issue? Do you know? Yeah.
Do you have any thoughts?
So the question was about solving the network latency problem when it comes to voice.
There is none.
That's a challenge.
Not right now. Not that I know of. I should say honestly, there are techniques like caching stuff locally, having an index store or metadata store to help you augment some of that stuff. So basically pulling some of your things that it repeats often, caching those locally and just sort of surfacing those to help smooth out the voice synthesis if that's a voice problem that you're solving or whatever the equivalent is for text. Similarly with diffusion-based models for graphics, sort of having those artifacts that are local be cached. So for gaming, for example, same solutions, but I don't know. Maybe you're the entrepreneur that's going to be solving that. That's why you wanted to validate. But I don't know of one company that uses this. The good news is a lot of these platforms like GCP, AWS, Azure provide, if their documentation is good, provide you with ways to optimize for latency.
And that's kind of where I was going, is that I feel like at least right now the best way we have to solve many of these problems is to make sure that processing is as close to your user as you can. And to do that, you need the big providers that are distributed around the world. Unfortunately, there are big providers that will do that, and their text-to-speech is pretty good these days. Is it great? Could always be better, but it's pretty good. I think the other big thing to keep in mind is they're also trying to improve it for their own use. The reason why Google has invested so much in some of this technology is because they want to do text-to-speech for Android, and the models that run on device aren't there yet. The devices aren't there yet. So they need to somehow get the text-to-speech to your phone as quickly as they can. So they're building out their system to do that. And you get to benefit from that. That's the good news. There's no magic bullet yet, though.
So if you join my talk at 3:25, At 3:25 today, talk titled Gen AI, an unreliable information store, ... and what to do about it. I talk about something called a distributed transfer learning pipeline, which, if you're familiar with federated learning, allows you to sort of run some of these models on the edge, which will solve your latency problem as well.
Well, I'm gonna take you to task for that for just a moment, Noble.
Yes, sir.
How much of that, and this is partly because it's one of my big issues, how accessible are those sorts of things to the everyday developer?
Not at all.
Okay, so,
Enterprise,
but even to the everyday enterprise developer.
depending on their use case, not at all.
Okay, and that's not a bad thing. I mean, I'll acknowledge this is work that needs to come.
And I have a solution for that,
Okay,
but I'll save that
we'll
for
save
later.
that for the presentation. Okay, good. And I only bring it up because this is my big cause these days, is making sure that we've got these LLM models. They're great, they're wonderful, and for the first time, everyone can use them.
I love how you use the analog of SQL,
Yes.
right?
Yeah.
Once relational databases became sort of the mainstay of how you persisted information, SQL was basically standard.
Right.
Standard query language, right?
I mean, I still remember when I was in university, and this was a long time ago.
Last
Don't
year.
say it. No. My database class, yes, half of the class talked about how to use SQL, but it was the second half of the class. The first half of the class talked about things like, how do you build indexes on disk? What are the data structures to optimize those? How do you time a spinning disk so that the answer to the question is under the media read head at the moment the question comes in?
Alan, you're dating yourself.
I know.
Let's just bring the,
But my point here is right now.
What is a disk?
Thank you. Right now, when we talk about AI, we think about the AI developers as this elite set of groups who know how to time a spinning disk for a database.
100.
And SQL brought it to everybody. And now things like OpenAI and Google's Vertex AI and LangChain have brought LLMs to every developer. And I think that's crucial for this technology to really advance. We got another question.
So when I think about agents, I've worked a little bit with the LangChain stuff, and I want to be able to essentially inform the agent once about the rules of the road for how to process input, and then give it input and have it use that. But I get the sense under the covers that every single time all of that system prompt is being fed, because it's a Kubernetes cluster and there's no memory, you have to feed it all those tokens every single time on every single thing. Do you know of anything that's going to change that? Because that becomes very expensive the more complicated the rules are.
Well, here's the thing. That is the fundamental underlying technology of LLMs right now, is processing every single token every single time. Now, maybe at some point, and maybe it's somebody here, is going to say, hey, you know what? This prompt is identical up until this point. Can we always pre-compute up to that point and then continue from there on out? Will we be able to do some smart caching like that? I don't know. That literally was something I came up with in 30 seconds. But right now, the fundamental underlying technology can't do it. There is no way to do it. And more importantly, it relies on the fact that you can't do it. It's
That's
not
right.
just, I mean, so the comment was it's disincentivizing for the big LLM providers to not charge by the token. Well, the answer is not all the problem is all the models work this way, and until a year ago, nobody thought about charging by the token. That's literally an invention of OpenAI. Nobody was thinking they were going to make money from this thing. It was going to be, I was going to have an LLM model, and I trained my LLM model, and I ran it on my server to do my stuff. It wasn't until OpenAI said, let anybody do it, that everybody said, oh, this has a use somewhere. And OpenAI said, yeah, how are we going to charge for this? Let's charge by the token. That works. So the comment again was it scales with CPU power. It does, and that's kind of the beauty of it, is that it directly lets you understand where you need to do tuning and where you need to make improvements. If you get a smaller prompt, it works faster, so it uses less CPU, so I can charge you for fewer tokens. There's a direct correlation between number of tokens and my cost to run it. In the same way, when we get these large context models, they take longer to run, therefore we're going to charge more just to use them, even for the same size input. There's direct correlations. And in some ways that's good, but it makes it tough to stomach the bill at the end of the month. I don't know how much time we have left. What are we at? We're at 1:41. So we've got a few minutes left. We have time for one more question if we have any.
Great questions, by the way.
These have been fantastic questions. One of the things that I like the most about coming to this conference in particular are all the different people that are out there that have these good questions that we'll meet with and talk with in the hall. Both Noble and I are going to be around some more. I know we encourage conversations afterwards. And for those of you that are here, I hope you tune into the pod. See, I have this trouble all the time. I do hope you tune into the podcast and continue to have these conversations with us every week. You can find us, we're both on LinkedIn.
That's right.
You can find both of us sort of on the system formerly known as Twitter. When this does get published, there will be comments. We'll take your comments. But most of all, I hope we hear from you. I hope you come and watch us another time at Two Voice Devs.
Two Voice Devs.
Thank you again, everyone. It's been great.